The reason CDUs are being installed in data centers is the liquid cooling we're providing to the rack cannot be supplied directly from the chiller itself. The chiller water might be too cold, it might not be clean enough, it might not be the right type of fluid. So by positioning a CDU between the chiller and the rack, it allows us to control the temperature of the fluid going to the rack, how much flow rate, how much pressure, and especially make sure that we're absolutely clean fluid going to the racks themselves and we don't have any debris contamination. So filtration is the number one concern when talking about cold plates, and this product allows these cold plate deployers to operate with security, knowing that their equipment has been protected. CDU operates by taking that chilled water, running it through our what we call the primary loop, and exchanging that heat in a liquid-to-liquid heat exchanger inside the unit. We then use pumps within the unit to circulate fluid on the secondary side to the racks and provide, again, that temperature, flow rate, and pressure that the servers need to operate efficiently. Our XDU 070. This is another CDU or coolant distribution unit, but this one is built with a different purpose. This unit is designed to go into facilities that don't have liquid cooling on site, so they don't have a chiller available and aren't able to reject that heat back to the chilled water plant. They have to rely on their existing air conditioning technology in order to remove that heat. Rather than having chilled water plumbed to the unit, we create our own secondary fluid loop between this equipment and the server next to it, supplying that chilled water or coolant water to the chips, to the cold plates, capturing that heat, and then returning it back here and passing it through a liquid-to-air heat exchanger and using fans to exhaust hot air back into the hot aisle, and therefore allowing the customer to use their existing air conditioning equipment to remove that heat and keep operating in an efficient set point. Looking at the other side here, you can see a lot of the same design philosophy. You know, two redundant pumps with independent filtration for concurrent maintainability. Same stainless steel reservoir for fluid makeup as air is removed from the system. And on the inside here, you can see the actual liquid-to-air heat exchanger itself, where we're pumping that hot return fluid from the cold plates through the heat exchanger and then rejecting that heat back to the cold aisle via air.
The system that we have here, I'm just going to describe it very quickly, is essentially an air-assisted refrigerant liquid cooling system. We have here on the main side a condenser and refrigerant repository that then pumps the refrigerant in a liquid form through to the server rack, and we're able to then hit the servers, and they have evaporators on them as they're processing and firing on those processes. The refrigerant will heat up, it'll vaporize, and therefore the cooling effect will happen. The vapor of the refrigerant will then return back to the system through a condenser coil, which is cooled through a fan-assisted system, which is resident in the data center facility, to then return back into a liquid state for the process to then reoccur. To describe that a little closer to you, I'm going to show you the actual accelerator cold plate system that we have here. This cold plate array supports 4 kilowatts of cooling. Attach this into the rack, into the server system, and that facilitates the harvesting of the heat and essentially vaporizing the refrigerant to assist the cooling methodologies. The reason why we developed this technology was to essentially look at the next challenges around total cost of ownership and the dollar per socket annualized to be able to operate these new systems. That plus our ability around sustainability aims to look at how we can elevate the operating temperatures and therefore drive efficiency gains is essential reasons why we developed this technology.
Hello, my name is Heiko and I'm happy to present the Reado heat exchanger, the Liebert DCD. Think about cold air coming off. When you open the door and you have your server equipment inside, it is incredibly hot. You close the door and all the air stays cold.